Normal distribution, Algebra 2 trigonometry regions. So on your reference sheets towards the bottom, you may have noticed there's this giant curve called the normal curve standard deviation. And we use this for normal distribution. And so this is given to you on your reference sheet. This will be given to you on my test and also on the regions. And so what does this really mean? Well, the middle here, the middle of the curve, and notice that it's symmetrical, from here. But the middle of the curve represents the average. And remember, we could use x with a bar over it for the symbol for average or mean. Then the zero point 0.5, the 1, the 1.5, the 2, the 2.5, the 3, and so on with the negatives, they stand for the amount of standard deviations. And so if you have an average, you know, let me look at this first example. The average 37 standard deviation is 2.5. Um, that's the kind of information that's given to you in these problems. Is you'll be given an average and a standard deviation. Like if we said there was, a group of people and the average weight was, 150 pounds, and the standard deviation is 10 pounds, then this one would represent one standard deviation above the mean. So this means one standard deviation above the mean. And so if the average were 150, and I'm just making these numbers up here, if the average were 150, then this one would be 160. For my demo, let's say the average or mean is 150 and the standard deviation is 10. So basically that would mean that 150, the average goes in the middle, and then the 1 is one standard deviation attached to the mean. The minus 1 is one standard deviation below the mean, so 10 below the mean. 10 below 150 is 140. The 0.5s are simply half. So if my standard deviation is 10, my 0.5 standard deviation would be half of that. It would be 5. So then you'd have 155 here and 145 here, and one. So it's 5 each time, or 10 if you're going by the whole numbers. And then the percentages up here represent the percentage between these things. And so the percentage, the ones that you really need to know are between -1 and +1 is roughly 68%. And you get that by adding up the percentages between them. So like a typical question would be, say, all right, so you say the average is 150, the standard deviation is 10. What percentage is between 140 and 160? So you'd put this on the table and say, all right, between 140 and 160, that's these numbers. You'd add up these percentages, and it would come out to be 68. So, but this is what we call within one standard deviation. So if you hear that terminology, we're talking about 68%. And sometimes it's simply that. What percentage is within one standard deviation? It's 68%. Now, 68% is a lot out of 100. That's, close to 70% out of 100. And that's what this is saying. This is a normal distribution. This is a kind of a phenomena that happens in nature. Like if you were to measure, the heights of the population, in your grade. Whatever that average height is, you would find that most people are pretty close to the average. Whatever the standard deviation happens to be, if it's a couple of inches, most people are pretty close to the average. It's a small percentage that's extremely tall and a small percentage that's extremely short. The vast majority of the population is close to the average. That's what normal distribution means. And this is what happens just in nature and everything. Um, so you'll see this come up a lot. So within one standard deviation is within the -1 and the +1, and that's 68% if you add all those up. Within two standard deviations would be the -2 to +2. So -2 over to +2. That comes out to be about 95%. So 95% is within two standard deviations. So those come up a lot. Within three standard deviations is like 99.9. There's 0.1% beyond three standard deviations in either direction. Let me do a couple of examples and show you how these questions really work out. So a standardized test, the mean or average score is 37, and the standard deviation is 2.5. All right, so if we go back to this curve here, and what gets a little messy is, you're only going to have one of these questions on a region, so you could just do the work on the curve. But we're going to do, 10 of them in class, and I'm not going to give you 10 curves. So what's a good idea is to kind of just draw a little sketch like this. So do 0, and then 0.5, 1, 2. Well, I guess I should do 1.5. 0.5, 1, 1.5, 2, and then you got negative zero point 0.5, negative 1, negative 1.5, negative 2. And if you need to add, you can. And so if you just put that down for each problem, and then fill these numbers below it, if your average is 37, that goes in the middle. And standard deviation is 2.5, so I'll add 2.5 to get here. So plus 2.5 would be 39.5. And again, I'm skipping the half. I could do halves, which I guess would be 1.25. But let's see if we even need them. I'll just fill in the ones. And if I need to go in between based on the problem, I can. So if I add another 2.5, that would be 42. And the minus 1, so I'm minusing 2.5 here. And minusing 2.5. And it actually works out that this would be your 32. And then this would be 34.5. And they want to know what percent is in this range, 32 to 42. And so now that you know that 32 represents the minus 2 standard deviations and 42 represents the positive 2 standard deviations, now you can go back to your curve and say, all right, from minus 2 to positive 2, what's the percentage between them? And that is what we set up here is 95% if you add all those up. So 95% would be the answer here. Let's do another. All right, let me set up that little bit right there. Average, and I'll just do the holes for now. Like I said, I could fill in the 0.5s if I need to based on what the problem's telling me. So, all right, the age of assume that the ages of first-year college students are normally distributed. That's the key word right there. When you see that in the problem, that's when you know you're using this curve. With a mean of 19 and a standard deviation of 1. So that's nice and simple. So that would be 20 and 21. Plus 1, plus 1. Minus 1, minus 1. 18, 17. To the nearest integer, find the percentage of first-year college students who are between the ages of 18 and 20. So 18 is the minus 1, 20 is the plus 1. So they're asking, so this is the minus 1 and this is the plus 1. How many are between that? The answer is 68%, because that's within one standard deviation. Between negative 1 and positive 1, between that, if you add these up, you get 68%. That's what they're asking for. Wrong way. So to the nearest integer, find the percentage of first-year college students who are between the ages of 18 and 20. That's 68% is between that. All right, to the nearest integer, find the percent of first-year students who are 20 or older. So 20 or older, 20 is at the plus 1 mark. Or older is basically saying, all right, we got the 20 at the plus 1 mark. What percentage is there and up? So now we're asked to add up all of these. And so we're looking at 9.2, 4.4, 1.7, and use your calculator. 9.2 plus 4.4 plus 1.7 plus 0.5 plus 0.1. It comes out to, oh, I don't know why I separated there, but plus the 13.6 comes to be about 16%. And so the answer there would be 16%. And that's kind of related to something called percentile, which I'm sure we'll have a question eventually. Percentile is the percentage that's behind it. So like halfway is the 50th percentile. This plus one right here is the 84th percentile because if I add up all the percentages behind the 1 mark, I get 84. Also was the reason why there were 16 above it. Um, so that's basically it. These questions don't need to really be complicated. They're just kind of a little strange because we have this giant statistic curve here. And this really isn't a statistics course. We just kind of sprinkle little statistics in there. But label it with your average and standard deviation, and then a lot of it's just what percentages between these things, and so you add them up here. All right, see you.